about it. So the volume is the measure of space that can be occupied by a 3D figure. And volume is measured in cubes or cubic units. So it's measured in cubic units, and if you remember in science, you might have done water displacement to find volume, because it's how much space, so when the water gets displaced, that's the volume of it. And I forgot what I was thinking. Oh, but it wasn't in cubic units probably, it was probably in milliliters. 1 cubic centimeter is equivalent to 1 milliliter. So that's where the connection is there. So it's still the same type of volume, but it's because it comes from 1 cubic centimeter is worth 1 milliliter, and then they convert. So the volume of a prism in general, and even a cylinder, because like I said, cylinder is similar to like a circular prism, is the base times height. Except the base isn't what we normally refer to as the base. Notice it's a capital B in that little formula. So in this case, when it's talking about the base, it's talking about how much space is there in the base. How much could I fill up on the bottom? So where base means the area of one of the bases. And then times height, that's how many layers I would have. Luckily for you, this year, you only need the rectangular prism. You don't need the cylinder, triangular prism, or any of those types. So for this year, all we need is the volume of a rectangular prism. So it still comes from the same place. So the volume of a rectangular prism is length times width. Because again, that tells you the area of the bottom, how many could fit on the bottom. And then times height, because that will tell you how many layers you have. Or how high you can stack it. So that's where the formula comes from, just length times width times height. But commutative and associative property, but you not necessarily worry about doing those 3 numbers in that order. You have that flexibility. So once they give me 3 dimensions, I go, ooh, volume? They're asking me how many cubic yards of mulch I need to order, how much sand I need for the sandbox, or how much water to fill that fish tank. And they're talking about how much I need to fill up something, how much space it's going to take. I'm going to just multiply those 3 dimensions. Something slightly tricky happens, though, when they give you a cube. So if they give you a cube, whether it's in words or it's a visual, they might only give you 1 number. So you go, oh yeah, I need length times width times height to find the volume, but they only gave me 1 number. So if you visualize a cube, you think about what makes a cube a cube. The length, the width, and the height are all the same measurement. So you multiply that 1 number times itself again. So the formula is going to look like S cubed. And I believe it's on your formula sheet. So the volume of a cube is the length of an edge. And for some reason, they abbreviated with an S. I don't know why they don't abbreviate with an E for edge. But on your formula sheet, it would be an S. Length of an edge to the 3rd power. So that number times itself, and then times itself a 3rd time. So you ready to try some examples? We have 3 examples. One's got whole number computations, one's a cube with decimals involved, and one is got fractions, and the units are a little funky looking. So I'm clearing it and scrolling it so we can do these examples. Find the volume of the rectangular prism. Again, partial credit by telling you what the formula is. A lot of you aren't doing that, but that's like a freebie point. Because even if you mess everything else up after that, at least I knew you were thinking about the right formula. So length times width times height. And that's the exact box that we were looking at yesterday. Remember we put index cards all over it? That's that one. So the length could be 28, the width could be 22, and the height could be 14. when I verbally talked about that box yesterday, at one point I talked about the depth. I said, it's this wide and it's this tall and it's this deep. So they might not even use the same terminology, length, width, and height. But as long as you get your 3 dimensions, you should know those are the ones I'm going to compute or calculate. Multiply together. Again, I can do this in any order. It's all multiplication, so I could choose whichever 2 I want to multiply first. And I have no rhyme or reason why I just did 28 times 22 first. So I'm going to do that computation. When you're doing this for homework or for practice, when you're doing it for a skill drill or something like that, get that calculator out and check after each computation. Because if I made a careless error somewhere in here, then I'm going to be doing the next computation for no reason because it was already wrong. So go ahead, 28 times 22, put in your calculator, go, yes! I got 616 and that's what I was supposed to get. So now I have to take that 616, multiply by 14. Do that computation. Try to do it carefully. Check with the calculator. Yes. You don't have to say yes, but you can think it in here. So every time you do a computation, if it's independent work or a skill drill or math box or something, where you're working on these problems on your own, it's not for a quiz or test, check with the calculator after each step.
When you labeled it, did you say centimeters squared or just centimeters?
What are these?
Cubes.
How many cubes would fit in, so it's centimeters cubed. So this particular box that we were looking at yesterday could fit 8,624 of these little cubes. That's a lot. We're not going to try it out. So you have to write the little cube sign after the label, not before it, because then you're telling me to cube that number, and that would be a whole even more lot of cubes. So centimeters cubed. And cubes would fit in is the volume. The next one, find the volume of the following cube itself. It's a cube. On your formula sheet, I believe it typically has that the volume of a cube is s to the 3rd power. Someone in the last class said, why is it s? There's no s when you're dealing with a cube. There's edges, there's vertices, there's faces. So for some reason they call it s as if the edge is a side length perhaps of one of the squares. So I think that's where the logic comes from there. So I'm going to want to do 1.2 times 1.2 times 1.2 again. So to do my first 1.2 times 1.2, raise your hand if you know what 12 times 12 is. Yes, sir. 144. And I ignored 1, 2 decimal places. So that means I have to put back in 1, 2 decimal places. And again, check with the calculator though, especially when there's decimals involved. Check with the calculator. Make sure you have your decimal in the right place. Now I have 1.44 times 1.2. Go ahead and do that computation. And I ignored 1, 2, 3 decimal places. So I'm going to put back in 1, 2, 3 decimal points. And it's going to be yards cubed. And then the last problem is another rectangular prism, but this time it's got mixed numbers. There's fractions involved. Unlike when there's whole numbers and decimals, don't take 2 parts, multiply them out, and then take the 3rd part and multiply it out. Because if you're dealing with fractions, you might be able to do simplify before you multiply more than one place. You have all 3 of them sort of laid out. We're going to see that in a second. No, because fraction problems need fraction words and fraction names. And this is a repeating decimal. You're going to be there forever writing 3s. Can't do computations with repeating decimals. It's not a control that thing. Right, so volume equals length times width times height.
And you can't round it up either.
So I'm going to do length, just picking the 4 1/3. It's somewhat arbitrary as long as you get your 3 dimensions. Width, I'm gonna pick the 2 1/2. And the height, I'm gonna pick the 6. So to remember to multiply mixed numbers, we cannot just multiply the whole numbers and then multiply the fractions like some of you still try to do. What do we have to do to multiply mixed numbers?
Round up the fractions.
Round
Not round
up the fractions. You might have the right idea, but that's not
word for it.
how we would explain it.
Make the.
Make them improper fractions. Make improper fractions. So this one would become 12/3 plus 1 1/3 is 13/3 times, let's see, 4 halves plus 1 1/2 is 5 halves times 6/1. So make everything improper fractions. Now raise your hand if you can tell me anything that I could simplify before I multiply. Because it's awesome to simplify what we multiply. The 6 and the 2 could be simplified, so the 6 would become what? A 3, and the 2 would become? A 1. But because I have all 3 things there, I think there's something else I could simplify before I multiply. What else could I simplify before I multiply? I don't have to limit myself to only doing it once. What do you see?
Oh, me? Oh, the 3 and the 3.
The 3's can cancel each other out. This 3 becomes a 1 and that 3 becomes a 1. Now I just have 13 times 5. Because over 1 means it's just going to be a whole number. Anyone in here know what 13 times 5 is? If not, you can do it off to the side. 13 times 5?
Oh, I don't know off the top of my head, but I know another way you could have done it would have been.
So I just want 13 times 5. Yes, sir. Mhm.
65.
65. But then we got a little bit of an issue with this problem. I can't write double notch cube. That just doesn't work that way. What does the double notch mean? And I used to always forever be messing this up. What's the double notch mean? Inches. So it's inches cubed. If you're like me and you mix that up, think about someone's height. Could be written as 5'8", for example. Or most of my friends, 5'3". I have not dismissed you. You should not be putting anything away. So feet is the single notch, and inches is the double notch. When you are writing your cubic units or square units, you cannot use the single notch or the double notch for your square or cubic units.